Okay, everyone, this lesson is on completing the square. Completing the square is a method that we use to solve quadratic equations. And that's what we'll start with here. A quadratic equation is an equation that we can write in this form: ax squared plus bx plus c equals 0. Here are some examples of quadratic equations. For instance, 2x squared minus x plus 5 equals 0. This, by the way, is called standard form for quadratic. One side is equal to 0. Here the a value is 2, the b is -1, and the c is 5. Another example, x squared equals 3x plus 1. It's not in standard form, but if I move everything to the left side, I can put it in standard form. X squared minus 3x minus 1 equals 0. And in this form, I can see that a is 1, b is -3, and c is also -1. Even this equation is a quadratic equation in standard form. It's just that the middle term is missing. It's actually a 0x. So in this case, a is 1, b would be 0, and c would be -9. Okay, so those are just some examples of quadratics. Now, to solve the simplest type of quadratic equations, we use the square root property here. Let's take an example. Supposing we need to solve the equation x squared equals 25. What the square root property tells me is that I'm going to get two answers, one with the plus sign and one with the minus sign. I'm going to take the square root of both sides. And on the right side here, I'm going to put a plus or minus sign there because I want both solutions. I want all the solutions to the equation. And as we talked about in a previous section, square roots actually do have two answers, a plus and a minus. On the left side, the square root and the square cancel themselves away and leaves you with just an x. On the right side, we have plus or minus 5. And so we've got two solutions to this equation. We've got a -5 and a +5. Here's another example of that. M squared equals 8. If I take the square root of both sides, don't forget the plus or minus sign there, I end up with m equals plus or minus square root 8. Simplify those radicals if you can. That would be 2 square root 2. And the two solutions to this equation would be -2 square root 2 and +2 square root 2. Here's another one. 3x squared minus 54 equals 0. I'm going to move the 54 over to the right side. And then I'm going to divide by 3. And 54 divided by 3 is an 18. 18, that's right. Now I'm going to take the square root of both sides, not forgetting the plus or minus sign, and I end up with x equals plus or minus the square root of 18, which, if you simplify it, is a 3 square root 2. And so the two solutions here are -3 square root 2 and +3 square root 2. And one more like this. Y squared equals 7. Take the square root of both sides. There's my plus or minus sign. On the left we have y, and on the right we have plus or minus square root 7. And since you can't simplify the square root of 7, you're going to leave your answers like that. Negative square root 7 and positive square root 7. Okay, now for this one, it looks a little different, but it's actually the same process that I'm going to do to solve this. I do have a quantity squared on the left side, in other words, a perfect square, and so the square root property will work on this. I'm going to take the square root of both sides. On the left, the square root and the square cancel away and leaves us with just x minus 3. On the right side, we've got plus or minus 5. Now, the best approach at this point is to split this into two different equations. If I use the plus 5, I've got x minus 3 equals a positive 5. And if I solve that for x, I get 8. 8 is one of my solutions. However, if I use the negative 5 instead, x minus 3 could be negative 5. And if I solve that equation for x, I get negative 2. And so the two solutions to this equation are negative 2 and positive 8. It would be very easy to check that both of these work. For instance, if I plug in negative 2 into the original here, negative 2 minus 3, if I square it, is positive 25. And also if I try 8, 8 minus 3 squared is also positive 25. So both answers work here. Let's try another one like that. 2x minus 3 squared equals 18. I'm going to take the square root of both sides. With our plus or minus sign. On the left, I've got 2x minus 3. And on the right side, if I simplify that radical, that's going to be 9 times 2 is 18, so it's 3 square root 2. Split this into two separate equations. 2x minus 3 could equal positive 3 square root 2, or 2x minus 3 could equal negative 3 square root 2. If I add 3 here, I end up with 2x equals 3 plus 3 square root 2. And dividing by 2, I get one answer. There it is right there. On the right side, if I add 3, I end up with 2x equals 3 minus 3 square root 2. And dividing by 2 gives me 3 minus 3 square root 2 all over 2. And so the two solutions to this equation are 3 minus 3 square root 2 over 2 and 3 plus 3 square root 2. 3 square root 2 over 2. Sorry, I think I said that wrong. And there they are, both solutions to the equation. Okay, let's try one more like this. 3k plus 1 squared equals 2. I am going to take the square root of both sides. On the left side, we'll just have 3k plus 1. The square root and the square cancel themselves away. On the right side, we have plus or minus square root 2. There's no way that we can simplify that. I'm now going to split this into two separate equations. 3k plus 1 could be the positive square root 2, or 3k plus 1 could be the negative square root 2. On the left here, subtracting 1, see, negative 1 plus square root 2, and then divide by 3, and I have one answer. There it is. And then over on the right side, my other answer will be let's see, 3k equals negative 1 minus square root 2. Divide by 3. And there's our second answer. And so those are the two solutions to my equation. Okay, very good. Now let's say I want to solve the equation x squared plus 10x, I'm sorry, 8x plus 10 equals 0. Now, I can't solve this equation by factoring like I would in a previous chapter. It just doesn't factor. So what I'm going to do is a process called completing the square. I'm going to move the 10 to the other side of the equation. I'll leave a little space in here, like that. And what I'm going to do is I'm going to add in a number right here that's going to give me a perfect square. The left side is going to factor to a perfect square. And to get that number, the process is I take this b, right, in the standard form that would be the b term, the b coefficient. I take half of that number, so half of 8 is 4, and then I square it. So half of 8 is 4, and then 4 squared is 16. And so I'm going to put a 16 there. Now, if I add 16 to one side of an equation, I have to add it to the other side to balance it out. So I'm also going to add 16 to the right side as well. So all I've done really is I've added 16 to both sides of the equation. Now, x squared plus 8x plus 16 here factors to x plus 4 times x plus 4. In other words, it's x plus 4 squared. I've completed the square. And on the right side we have 6. This process always works where we take b and divide it by 2 and then we square the result. It's actually this number right here. You take b, you divide by 2, and you square the result. That will always make the left side factor to a perfect square. Now, in this form that I have here, I can now solve this equation the way I was solving the previous equations. I can use the square root property. So I'm now going to take the square root of both sides of the equation. On the left side we have x plus 4. On the right side we have plus or minus square root 6. Splitting that into two parts, x plus 4 could be positive square root 6, or x plus 4 could be negative square root 6, negative sign. If I solve this equation, I get negative 4 plus square root 6, and if I solve this one, I get x equals negative 4 minus square root 6. So the two solutions to this equation are right there. I have solved my equation by completing the square. Let's try another one similar to that. Solve. X squared plus 2x minus 10 equals 0. Move the 10 to the other side and leave some space in there. Now remember the process here is I take my b, divide by 2, and I square it. So this is my b. 2 divided by 2 is 1, and then I square it, and I get 1. So positive 1 is the number that I have to add to both sides of the equation, so I'm adding it over here as well. If you look at the left side, x squared plus 2x plus 1 factors, this right here, factors to a perfect square. It is x plus 1 times x plus 1, or in other words, x plus 1 quantity squared. And on the right side, we have 11. There it is. Okay, I've completed the square. I can now solve this equation by taking the square root of both sides. On the left, we have x plus 1, and on the right, we have plus or minus square root 11. So x plus 1 equals positive square root 11, or x plus 1 could equal negative square root 11. My two solutions are negative 1 plus square root 11 and negative 1 minus square root 11. Both solutions to our equation. Well, let's try one now with a fraction. X squared plus 5x minus 1 equals 0. Okay, to solve this quadratic, I'm going to complete the square. I first move the 1 to the other side. Okay, now I take half of 5 halves, and then I square it, which gives me the fraction 25 over 4. Sometimes you have to add fractions to both sides of the equation. So I'm going to add that also to the right side, 25 over 4. Now this left side does factor to a perfect square. It's x plus 5 halves times x plus 5 halves. And an easy thing to remember what number goes here, it's always this b term divided by 2. So that's that number right there. It's b over 2 there. It's always half of that. Now on the right side we have, let's see here, we need a common denominator. 1 plus 25 over 4. I've got to multiply that by 4 over 4. And so I'm going to have 29 over 4. X plus 5 halves squared is equal to 29 over 4. Okay, I've completed the square. I can now solve this equation by taking the square root of both sides, which I will do up here. Square root of both sides. Don't forget the plus or minus sign. On the left side, we have x plus 5 halves. And on the right side, we have plus or minus square root 29 over square root 4. I used my quotient rule here and wrote that as two radicals. I do know what the square root of 4 is. It's 2. So x plus 5 halves is equal to plus or minus square root 29 over 2. Now, if you're careful, you don't have to write this as two separate equations. You could just keep the plus or minus sign. Subtract 5 halves from both sides. Put that negative 5 halves in the front of the radical like that. And I get x equals negative 5 halves plus or minus, I'm writing that right there, negative 5 halves plus or minus square root 29 over 2. And that actually represents my two solutions. If I write them both out, negative 5 halves plus square root 29 over 2, negative 5 halves minus square root 29 over 2. And both solutions to my equation. Next. Solve. 2x squared minus 4x minus 5 equals 0. Now, I'm going to move the 5 over to the right side. But there's one extra step involved here, and that is this. For completing the square to work properly, I have to have my a coefficient equal to 1. This must be a equals 1. For me to add a number to both sides and get the perfect square correct, that has to be a 1x squared there. So in this case, what I'm going to have to do is divide everything by 2, like that, so that I now have 1x squared minus 2x equals 5/2. So I've got the 1 there that I needed. Now I can complete the square. The number that I need here, I take half of 2, or negative 2 actually, half of that, which is negative 1, and then I square it, which is a positive 1. And so I'm going to add 1 to both sides of the equation. The left side factors to a perfect square. It's x minus 1 quantity squared, and that equals 5/2 plus 1 is 7/2. I've completed the square. I can now take the square root of both sides. Here we go, square root of both sides. Plus or minus sign. X minus 1 equals plus or minus, let's fix that, square root 7 over 2. Let's see, square root 7 over 2, square root 2, quotient rule, and I want to rationalize the denominator, so I got to, if I do that, I got to multiply by square root 2 over square root 2. Rationalize. That gives me x minus 1 equals plus or minus square root 14 over 2. I rationalize the denominator there. Move the 1 over. Add 1 right there on both sides. Make sure you put the 1 in front of the radical, not behind it. And we end up with x equals 1 plus or minus square root 14 over 2. So my two solutions are 1 plus square root 14 over 2 and 1 minus square root 14 over 2. Solved. Let's try another one like that. Three z squared minus 6z minus 2 equals 0. Solve. Okay, I'm going to move the 2 over. And then remember, we need to get rid of that 3, so I'm going to divide everything by 3, both sides of the equation. Gives us z squared minus 2z equals 2/3. Now I add on the number to complete the square. And this one's similar to the last one. I take negative 2 and I divide by 2. It's negative 1. And then I square the result. So I'm adding 1 to both sides of the equation. The left side factors to the perfect square z minus 1 squared. And on the right side, if I add my numbers together there, I get 5/3. I've completed the square. I can now take the square root of both sides of the equation. I end up with then z minus 1 on the left, and on the right side, square root 5 over square root 3. Remember to rationalize this radical. You don't want any radicals in the denominator. So I'm going to multiply square root 3 over square root 3, which gives me z minus 1 equals plus or minus square root 15 over 3. Add 1 to both sides, and we end up with z equals 1 plus or minus square root 15 over 3. And those are my two solutions to the equation. 1 plus square root 15 over 3 and 1 minus square root 15 over 3. And our quadratic equation is solved. Let's now look at some quadratics where we get complex solutions. X squared equals negative 9. No need to complete the square here. I've already just got an x squared on the left side. So to solve this equation, I would take the square root of both sides. Don't forget the plus or minus sign. On the left side we have x, and on the right side we have plus or minus square root of negative 9, as we learned in a previous section, is the imaginary number 3i. And so this equation has two imaginary solutions, negative 3i and positive 3i. Y plus 2 quantity squared equals negative 16. The square is already complete here, and so I'm going to just take the square root of both sides. Plus or minus sign there. On the left we have y plus 2 because the square root and the square there cancel out. And on the right side we've got plus or minus square root of negative 16 is the imaginary number 4i. Now you can subtract 2 from both sides. Make sure you put the negative 2 in the front of the imaginary number like that. And we've got y equals negative 2 plus or minus 4i. So I have two complex number solutions, negative 2 minus 4i and negative 2 plus 4i. Here's another one. X squared plus 2x plus 7 equals 0. Okay, I'm going to need to complete the square on this to solve using the square root property. I'm going to move the 7 over to the left side, or to the right side that is. The number that I need to complete the square, I take half of 2, which is 1, and then you square it. And so I need to add 1 to both sides of the equation. The left side factors to the perfect square, x plus 1 times x plus 1. X plus 1 squared. And that equals negative 6. I've completed the square. I can now take the square root of both sides to solve the equation. Square root of both sides. The left side simplifies to x plus 1. And the right side, square root of negative 6, that's the imaginary number I square root 6. If I move the 1 over to the right, it becomes negative 1. And my solutions are negative 1 plus or minus I square root 6. Writing those out separately, negative 1 minus I squared 6 and negative 1 plus I squared 6. Two complex number solutions. And there they are. One more example. One more example of completing the square. Solve. 5x squared minus 15x plus 12 equals 0. All right, I'm going to move the 12 to the other side. Becomes negative 12. And remember, to complete the square correctly, this leading coefficient must be equal to 1, so I'm going to have to divide everything, both sides, by 5. And that will give us x squared minus 3x equal negative 12 fifths. Okay, so what number do I need to complete the square? I have to take half of negative 3, which is negative 3 over 2, and then I have to square that. And if I square that number, I get a positive 9/4. And so 9/4 is what I have to add to both sides of the equation, 9/4. The left side does factor to a perfect square. X minus, and remember that this number here is always just half of this. It's right there. And so that's minus 3 over 2 squared. If you were to FOIL this left side out, you would get this back. On the right side, we have to add those fractions together. So common denominator, let's see, would be 20. Let's see what we can do here. Common denominator of 20. So I multiply this by 4 over 4. This one by 5 over 5. X minus 3/2 squared will equal, let's see, negative 48 plus 45. Looks like it's negative 3/5. Negative 3/5. Okay, I've completed the square. I can now solve this equation by taking the square root of both sides. So square root, don't forget the plus or minus sign. On the left we have x minus 3/2. And on the right side we've got plus or minus. The square root of negative 3/5 is I square root positive 3/5, imaginary number. Of course I want to rationalize that though. That's square root 3 over square root 5. To rationalize this fraction, I got to multiply it by square root 5 over square root 5. That will give me x minus 3/2 equals plus or minus I square root 15 over 5. Add the 3/2 to both sides. And we get x equals 3 over 2 plus or minus I squared 15 over 5. And so the two solutions to my equation are 3/2 plus I squared 15 over 5 and 3/2 minus I square root 15 over 5. Solved. And that is how we solve equations by completing the square.